Hey, today I'll be solving another LeetCode problem. So today it's find the duplicate number. So based on what I've seen, this is a pretty interesting problem to solve. And I'm basically making this video because the resources out there was not very intuitive to follow along for me, especially with how the algorithm was explained. So hopefully I do a better job of explaining it. So for starters, we have to look at the easiest way to solve this problem. So we have to find a duplicate number, and we are given that the duplicate number is only one. So there's only one duplicated number in our array. So for example, we have an array of 13422, and the duplicate number is 2. So we could solve this by like throwing all of this in like a hash set or a hash map, and basically whenever the frequency of a number goes beyond 1, then we know that it's our duplicate number. So we could just return that number and end the problem. But we're forbidden from using any extra space. So using like a hash set on a hash map would take O of n space. So we have to solve this in like O of 1 space. And we are also forbidden from modifying the array. So we can't sort it or something like that. So for example, if we sort it, it would be 1, 2, 2, 3, 4. So the duplicate numbers would end up right next to each other. So this is a pretty easy solution too. So if they end up right next to each other, we just have to compare the numbers around it. So we could solve all of this in like O of n2. But we are forbidden from modifying the array, so we can't do that either. So the main core intuition behind this is to recognize that it's a linked list problem. So how do you do that exactly? So the details pretty much point to it. So we're given that it's a n plus, the length of the array is n plus 1. So our example 1, n plus 1 would be 5 for example 1. And so n would be 4 plus 1. And we are also given that our range would be in the range of 1 comma n. So in our example 1, our range should be 1 comma 4. So each element in the array should be between the range of 1 comma 4. So once we have this, how do you recognize that it's a linked list problem? You have to think of each value in the array as a pointer. So it's not really easy to do that. So it's not really natural either to think of like a normal array as like a linked list. But there's no other choice. You have to recognize that like when you brainstorm, you have to basically come across a correlation that like each element in the array has like a pointer. So if you think of it as a pointer, this would basically form a cycle. If you build a linked list out of this of any array in our test cases, it would form a loop. Why exactly? Because our linked list is in the range of 1 comma n, and we also know that it has a duplicate number, so it should form a loop. So I will demonstrate how it forms a loop by using our example 1 here. So we start from the 0th index, and at the 0th index we have the number points to 1, and at our 1th index the number points to 3, and at our 0, 1, 3 the number points to 4. The number points to 2, and the 2nd index points to 4, and our 4th index points to 2. Can you see that it makes a loop? So once you realize that it's a linked list cycle, it forms a linked list cycle, you would know that this is a linked list cycle problem. So whenever we have cycles involved, to detect a cycle, we use something called the Floyd's algorithm. So you also have to know the Floyd's algorithm to solve this. You have to know the Floyd's algorithm to solve this, and you also have to know that it's a linked list cycle problem. Once you have two of these pieces, the rest should come easily. So first, to explain the intuition behind why our optimal solution works, I will tell you the algorithm first, and I'll just explain the intuition behind it. I won't really get into the mathematical proof. So hopefully it's easy to understand then. So I'll use a different example I found in someone else's resource. Shout out to LeetCode. So for starters, we have like I'll create a linked list cycle. So something like this. So, and so take this as like a array of nums in our test case. So there's an array that forms this cycle basically. And once we have this cycle, we use the Floyd's algorithm where we basically have 2 pointers, slow pointer and a fast pointer. So the Floyd's algorithm basically works by incrementing the fast pointer by 2 and slow pointer by 1. So we have to do this until our slow and fast pointer intersects. So let's say our slow pointer makes 1, 2, 3. It makes 3 jumps to get to here. In those 3 jumps, our fast pointer should go 1, 2, and 3. They should intersect at this point exactly. So once we have this, we break the loop. Once they intersect, we break the loop. And once we break the loop, we initialize like a second slow pointer, and we start both our slow pointers from the start in another loop. So we do that until both of our new slow pointers intersect, and they should intersect at the beginning of the cycle. So why does the beginning of the cycle matter, and why does our loop work? So for starters, our beginning of the cycle matters because like the cycle would form when where the duplicate number is. So for example, our cycle forms at 1 here. So in our array, that should be our duplicate number. So in the previous example that I showed, our cycle formed at 2. So the cycle was like this. So it was the duplicate number because it had multiple nodes pointing to it. So that's precisely why it's the duplicate number and why the beginning of the cycle matters. So I have explained why the beginning of the cycle matters. The next point is to explain why our algorithms work exactly. So how do we know that like our second slope, the two slope pointers would always intersect at the beginning of the cycle? How would that work exactly? So I'll re-demonstrate again, but this time I'll explain why the core intuition works. So I'll make like a new example. So 1, 3, 4, 5, and let's say this is our cycle. And why would this work exactly? So for starters, our slow pointer is here, fast pointer is here. So where would they intersect? So I'll increment the slow pointer by 1, 2, 3, 4. They should intersect here, and the fast pointer should intersect 1, 2, 3, and 4. They should intersect here. So how do I know that it intersects here? So to look at that, we have to invert the problem. So instead of looking at the extra node or anything like that, just look at a cycle, for example, 1, 2, 3. Just look at the cycle here. So if we use the Floyd's algorithm here, fast pointer and slow pointer, if we increment it twice the speed and the slow pointer, they would always meet at the beginning of the list when they end. So why does this happen? Because the fast pointer always moves at 2x the speed of the slow pointer. It moves at 2x the speed. So when you have like an extra node here, so it's kind of getting messy. So when you have a extra node here, then it would basically offset it by 1. So our instead of our slow and fast pointer starting here, we started at here. So if we started here, it should not meet at 1. Instead, it will meet at 3. So basically, our entire algorithm is basically offsetting the intersection of both of those before the beginning of the list, or how many nodes that come before the beginning of the list. So hopefully that explains it. So it was still pretty much a mess. So if you have any questions, just comment them below, and I should be able to explain them. Or hopefully, if you have more problems, I could just message or something like that. Okay, so with the explanation out of the way, I'll get to the coding part. So the coding part is pretty trivial in my opinion because both of our suboptimal and optimal solutions are lesser than 15 lines of code max. And so to start things off, I'll demonstrate the easier solution that I talked about, at least one of those, and then I'll get to the more optimal solution and I'll demonstrate the comparison in performance. So for example, we have to start with the hash map. So let's initialize a hash map, and I'll use something called default dict because I just prefer using it because I don't have to deal with any default values or something like that. So we basically just look through the array, and we basically add each value's frequency when it appears in our loop. So, and we basically check if that corresponding frequency for each value is greater than 1. If it is greater than 1, we know that it's like our repeating or duplicate number. So in that case, we just return the num, and we don't really have to worry about any extra conditionals because we know that we would always have a duplicate number. So let's just run this, and it's accepted. So I'll just submit it. Yeah, it is accepted, but as you can see, we are using O of n memory. So I'll get to the second solution now. So if you remember my solution from before, then my explanation from before, you would know that like we have to first use the Floyd's algorithm to find the intersection point. So we have to use Floyd's algorithm to find the intersection point, and once we have to use a second slow pointer to find the beginning of the list. Intersection point or find the offset. So we use the first Floyd's algorithm to find the offset and the second slow pointer to find the beginning of the list. So for example, we'll start with slow and a fast pointer, and we increment slow pointer by 1, and at the same time we increment the fast pointer by 2. Oh, my bad. Yeah, I can't really type today, so with that out of the way, when they intersect, we have to break the loop. So if slow is is equal to fast, we break. And then once that is done, we just have to need a second slow pointer. We could just reuse our former fast pointer as our new slow pointer. So we'll have a new loop. So here we'll just increment both by 1 until they intersect. So, and when they intersect, we have to break. And then we just have to return just one, either fast or slow, depends on what you like. So I'll just go with fast. So yeah, this should work technically if I don't have any bugs. So let's see. Yep, it works. So yeah, the memory improves, but I'm not sure about this. So yeah, hopefully I cleared up any problems you had with this and on your understanding. If you still have any questions, please comment them down below. I don't mind helping anyone out. And if you have any extra problems that you need help with, let me know. So